As I was thinking about what I should talk about today, I had a lot of things come up in my mind, but the overwhelming thing that I really wanted to talk about is why don't we actually do what we know we should be doing? So this is actually more complex than just money, I think. I think money is a big part of it, but there's also a huge component that's not quite there. And I'm going to preface this talk with, these are all kind of like ideas in evolution that I think, have a lot of merit in them, but I'm definitely still changing them as we go along. So why don't we build better buildings, right? We've had so much innovation in the buildings industry. We have better codes and better standards. No, they're not perfect, but they sure have improved over the years. We've started developing new technologies and new approaches to buildings. So for example, we've got a more mass timber build up there. We used to not be doing those so high. We've started testing our buildings better. We now know how they perform more. You can spot Greg up in that photo there that I've ripped off from his testing. And we've done some really great improvements in terms of things like energy intensity reductions due to efficiency measures. We've also started into this whole world of digital controls and optimization and so on, right? But these are things that we talk about, and sometimes we sure do them, but they're not widely integrated. I think that would be a far cry to say. When we look at our buildings, right, and some of these you're going to see right away what's wrong with them, but I think all of these are quite wrong. So perhaps we can start with the obvious, right? We've got our window with a good leak, right? Obviously, we should know how to build that without leaking, right? But it's just not getting done. This was actually a new building that I stayed up in Whitehorse in that was probably built around, 2022 or something. I was there 2025. This I ripped off of Greg, so you can ask him more about the context later. But this image is basically showing construction that has multiple exhaust and intake inlets, including for your fresh air intake, all beside each other, right? So we can think that that's not doing great things for us. This one's a little more obscure, but this is one of my most hated things. You can see a little bit more in the reflection. You're seeing a kitchen here. And this is one of our beautiful condos in downtown Toronto, where every single bedroom has a glass opening into the main living area, presumably so you don't have to have a window in it and can meet your natural lighting requirements. But clearly, this was actually, there's a Toronto Star article on this condo that's out recently, sold for just over $300,000, says it's a 3-bedroom condo. Obviously unusable, right? So I want to talk a bit about some of the propositions about why these things remain, even when, in theory, with policy and so on, we should be addressing them. Right? We make improvements for fire code, but when we can't really visibly scale or see the impacts that are happening, we tend to underestimate the risk. And this is very much a proven psychological theory that happens, right? Humans are very susceptible to the availability bias. We're really great at recalling events like the Grenfell Tower fire that are visible, memorable, and dramatic. And so when we see these events, they come back to mind. We're afraid of them. We know this is something that could happen. We know we can die. And I'm not saying we should not be investigating these. Clearly, we should be. However, what I would like to propose is that actually most of our building-related harm is fairly invisible, cumulative, and long-term. And so it's something that's very invisible to us personally, because it's not something that I'm breathing in this air today. I am going to be sick. Well, maybe if it's COVID, right? But you have all of these factors that are coming together. So for example, particulate matter in our air quality that are impacting our long-term health and causing significant challenges in terms of healthcare and premature death. If I had my speaker notes here, I could quote you some vague percentages on how much exposure to moisture, dampness, and mold impact asthma outcomes. I think it's like 20 to 30% increase or something. Ask me later or look it up. You don't need the facts. I'll just give you the important parts. Just trust me to synthesize them. But, right, we can also think of these in terms of things like heat stress. Heat stress obviously can cause direct death, but it also causes other mental health and productivity issues. So one thing that we've been looking at, for example, with the Center for Addictions and Mental Health is the impact of extreme heat events on schizophrenia and its prevalence, right? It's something we're still trying to look into more, but there is very clearly this strong link. Some of them that we see here, like in terms of density and design, right, you can think of overcrowded buildings. An overcrowded building has very significant mental health and long-term socioeconomic outcomes that are impacted by it, right? So in an overcrowded building, if you think about a child may not be able to study in the building. There are also mental health impacts in terms of having so much lack of privacy, I suppose, and so much stimulus going on around you. And these don't stop then when you move out of the building because, of course, they're iterative long-term effects. And the reality is that as design professionals and people working with buildings, all of our small, tiny choices that result in these seemingly almost innocuous errors and issues are having long-term impacts and significant effects. But because they're not really sensational, maybe someone's investigated this one. Some of these things are a bit hard to find images for because they're so blah. But if you think about the Grenfell Tower fire, you had a single incident in time. You had a certain amount of people die. Very sad, very bad, of course. We used $430 million for investigation into this. One single event. Yes, it impacted other buildings in the UK. However, when we look at these things that are happening in almost every home or every building, we're not really doing anything. Maybe in major cases, we're investigating, but we can't really see the risk because it's so kind of cumulative and long-term. Okay, so that brings us to 2. The idea that not everyone benefits from better buildings. And this is probably a bit of preaching to the choir here. You guys already know this. But we don't implement our better buildings in a way that they actually reach everyone. So we know that IEQ issues, so indoor environmental quality issues, are more impactful in our vulnerable communities, who in theory are actually having worse outcomes from these impacts. What we end up with is also seeing, though, that these households or applications within the industry that need it the most are not getting funding to have work done towards, right? I think from us as researchers, right, it's a lot easier to work with a commercial building that has money, has the capacity to implement something, and to work towards a technological improvement there. And you do see that significantly with, say, for example, advanced controls, or even just commissioning of a building. Okay, so the third idea that I want to talk about is the idea that those who make decisions are not necessarily the ones who bear the consequences. This is something that comes up so much in my work. We can think about especially condo buildings, because we're in Toronto, right? This is now from 2011, so a bit of ages ago, but it still rings true, right? A lot of the issues that we're seeing in condo buildings is that the upfront or capital cost is really being borne by the developer, whereas they have no incentive to decrease the long-term costs because they are not involved in the operation of the building. Yes, money. So this challenge presents itself in different ways, right? It's not only happening in condo buildings, but it's one of those most obvious examples that we can think of here. So I do want to point out, though, that this system's working exactly as it was designed. It's just not working for the people who live in it. So it's working for the developers mighty fine, I'm sure. They don't got to be on the hook for their defects beyond the appropriate period. All right, and this one should be quite familiar, but it's the idea that every new technology or change is actually interacting with everything else. So I hope at this point everyone in this room has heard of the building as a system concept. But if we look at this nifty diagram here that I pulled from way back in my PhD, Marianne should recognize it, right, you can see that if we think about how all these systems operate, any change to one will result in a change to another. So if we're changing how our thermostat controls are operating, we're changing how our suite HVAC's operating, eventually our buildings, right? We've got influence with the envelope. Everything is changing all of the time. Oh, good. I'll end early. Don't worry, Kevin. So all of that to say is to come to this single conclusion that better buildings are not actually a technical problem. That's not to say we don't need more technical evolution. Obviously, there's a lot of evolution and improvements we can make. But the fact is, if this was a technical problem, it would have already been solved, right? And the fact is that good technology and intentions are not good enough in this instance, right? You can try to build a better building, but if you're not aware of all the cascading impacts that your changes are having, or if you're working against stronger forces, you can't do it. All right, so what would a new approach look like? Well, in reality, this needs to kind of answer some of those ideas. And this is where it falls apart a little bit in terms of it's impossible to do, right? I think many of us have tried to do this and failed and been sad. Maybe just got sad and didn't try. Okay. But I do think there's some ways that we can approach it. So one thing that we can start looking at is making invisible risk visible. And this is a lot of the work that we do in my research group in terms of low-cost sensing that can be deployed in buildings that don't have $5 million to add sensors to, right? So for example, this is a dashboard that I built for, I don't know, the sensor's probably $70, measures relatively accurately particulate matter, CO2, and so on. Like, it's not great, but it's good enough for a benchmark, right? And this visualization, of course, is not perfect. It's kind of ugly. But, you know, first hack at in my spare time, right? So if we can start to show people what their indoor environments are doing, at least they can take some mitigating actions, right? We've established that they're not necessarily fully in control of their environment. So perhaps they are not able to really fully mitigate the situation. But at least the data will allow them to advocate for themselves or perhaps do some small interventions for themselves to help, right? It's not really enough to be doing dashboards because we need to be able to tie this to long-term kind of co-benefits of improving indoor air quality. But, you know, we have to start somewhere and eventually move on to the future. I think this is something else that kind of really, it feels very squishy and maybe like we're like whipping ourselves a bit to say it. But I think one thing that's very important to kind of resolve some of these issues is building a better culture of accountability and reflective praxis. So something that I really have gotten a lot of inspiration from recently is like in aviation and the pilot debrief that happens there, which is a facilitated debrief process. In which the idea is not to assign blame over things, but to actually fully investigate and understand what happened that could cause a scenario to occur. And so we don't really do this in industry or in academics. None of us do it. We don't do this in buildings. Sometimes we'll talk about our success stories, but you see a lot less discussion over what went wrong, and we don't see full investigations into what went wrong. And actual personal humility into our roles in doing that. So I think that's one thing that's kind of a very critical piece for us to implement as an industry. You know, you're already kind of doing it by coming to this kind of event, but you know, we need something a lot more structured that's happening all the time. The other thing that I think is important to think about with this is, I believe the last presentation, there was something said about not just doing something because you've always done it that way. Or maybe that was somewhere else. I don't know. I just heard that recently. But that's one of the things that's got included in this. I'm on one of the task groups for the building code review in this term. And one of the things we're really trying to get out is those stupid recirculating kitchen fans that don't work. They don't work. They don't filter out the contaminants. You need to exhaust the air. And so you get a lot of comments coming up in it that, okay, well, we've done this before. We felt that there was success for this. We've done X, Y, Z. But in reality, I suspect that people feel it was a success because they haven't gone back to check or looked at the long-term implications. If you want to talk about using HRVs for kitchen exhaust, talk to Greg. I think he has some opinions on that. So I think thinking about why we want to be doing things the way we're doing them and not just relying on I have always done it this way is really, really, really important. And constantly reevaluating how we do things. Oh, I cut off some of my text here. So I think the other thing, and this is really hard for us to do as individuals, is to reconnect the decision and the consequences. And so this is something more that we need to advocate for with policymakers, right? But how do we make sure that whoever is designing and building this building is responsible for the long-term ongoing costs and challenges in it? It has to be done. Is it politically favorable? No. What is the way to do it? I don't know. I don't know. This is one of the things that always hooks me up, and I'm like, maybe I should just like quit and get out of here and move to somewhere else, because we're all gonna die. It's, yeah. So on that doom and gloom note, I think one of the last things that we need to think about, and this also is very vague with no real implication or no tangible ways to implement it that I have to suggest, is to make building solutions accessible rather than exceptional. So right now, I chose this picture because of digital twins. And digital twins come up so much, and nothing pisses me off more than a digital twin. One, because it's just a model. Why do we need to call it a digital twin? You're just trying to get grants. Two, it is because digital twins are something that are so very inaccessible to anyone but people with strong resource, like very highly resourced people. So my question is always with these technologies, how do we translate them to an affordable way, right? That's part of the thing that we're trying to do with the low-cost sensing, is to say, okay, we can get you a $60 sensor instead of a $450 sensor, right? That helps a lot. Is it ideal? No. There's also challenges with people having the capacity to interpret information. So I think there's a huge multitude of things that come into this. And maybe at this point in where we're at, it's just thinking about it and being aware of it as we work on developing new technologies or implementing them. I don't have the answer, and I would love for people to give me ideas about it. So that brings me to my end. Feel free to find me, I will be around, or send me an email at some point. So thank you guys.